This is AB Calculus, section 4.3, page 8. Today we're going to be sketching graphs of functions and their derivatives. Starting with the graph of f prime and the zeros of f of x right over here, I want you to sketch a reasonable graph of f of x, and we're to assume that f of x is continuous. So again, this is the graph of the derivative, and I'm telling you the zeros of f of x. And down here, way in the bottom, we are going to sketch a graph of y equals f of x. That's what we're looking for. All right, let's start. The first thing that we want to do here is to find the critical numbers of f of x. And remember, critical numbers come from where f prime is equal to 0, where f prime is undefined, and where f prime does not exist. These aren't going to show up just yet, so we're going to kind of hold off on those. Where f prime is equal to 0. Now remember, this is the f prime graph over here, so we want to know where this graph is equal to 0. That graph is equal to 0 at x equals -1 and also at x equals 1. F prime undefined, we're looking for these vertical pieces. This piece going up toward positive infinity, this piece going down toward negative infinity. Slopes increasing without bound, slopes decreasing without bound. So these are going to be our places where f prime is undefined. Once we have those critical numbers, then we'll go ahead and create this super chart down here, setting up the intervals with our critical numbers here. So we'll have x less than -1, at -1, for x between -1 and 0, at 0, between 0 and 1, at 1, and x greater than 1. And then we'll start to fill in these columns. F of x, the only thing we know are these zeros. So we know that f of x is 0 at -1, and we know that f of x is also 0 when x is 1. When we start looking at f prime, again, this is the f prime graph, so when we want to know about f prime, first from our critical numbers, we know that at x is -1, f prime was 0. Also at x is 1, f prime is 0. And when x is 0, f prime was undefined. All right, now, because this is the f prime graph, when we fill in this column, we will be looking for places above or beneath the x-axis. And when x is less than -1, the graph of f prime is below the x-axis, so f prime is negative. For x between -1 and 0, that's this section here. Again, when x is in here, f prime is beneath the x-axis, so f prime is negative. For x between 0 and 1, the graph of f prime is above the x-axis, so positive. At x equals 1, f prime was 0, and when x is greater than 1, f prime is negative. All right, let's use that information then to fill in this description of f of x. If f prime is negative, that means that f of x is decreasing. When f prime is 0, that means that f of x has a horizontal tangent. When f prime is negative, that means that f of x is decreasing. F prime undefined. All right, undefined because we're going toward these positive and negatives. That's leading us toward a vertical tangent of some sort. F prime positive means that f of x is increasing. F prime 0 means that f of x has a horizontal tangent. And f prime negative, again, means that f of x is decreasing. We have some more information to fill in here, and it's probably easiest to start down here at the bottom. If f of x is changing from increasing to decreasing, f of x is changing from increasing to decreasing, there has to be a relative maximum in there. And right here, when f of x changes from decreasing to increasing, decreasing to increasing, there has to be a relative minimum. Right here, though, f of x changing from decreasing to decreasing, there's no relative extrema there. It's just decreasing to more decreasing. All right, once we have that one, then let's go ahead and look at f double prime. And f double prime is the derivative of f prime, and a derivative describes slopes of tangent lines. So when you're filling out an f double prime column from an f prime graph, we will look at slopes of tangents. Of f prime. All right, so when x is less than -1, slopes of tangent lines here, those are positive. At x is -1, the slope of the tangent line is 0. For x between -1 and 0, slopes of the tangents are negative. At 0, there is no tangent line, but we have this vertical situation going on here, or these approaching infinities, that's undefined. And here's the deal. Once you get one derivative to be undefined, every derivative after that is also undefined. For x between 0 and 1, slopes are negative. Be careful here at x equals 1, though. Some of you will want to just say 0, and that slope is not 0. At x is 1, there's the slope of the tangent line right here. That slope is not 0. That slope is negative. We don't know how big it is, but it is negative. And for x greater than 1, the slope is negative. Now we'll write descriptions for f double prime. When f double prime is positive, then f of x is concave up. F double prime is 0. We have a possible point of inflection. When f double prime is negative, f of x is concave down. All right, let's fix this possible point of inflection right here and determine if it is or isn't. We definitely have a change in concavity. Is there a tangent line here at this point? Yes, there is. There is actually a horizontal tangent line, so that's not a possible point of inflection. It actually is a point of inflection. Can't say anything about this one with an undefined f double prime until we look at the next one, and we have concave down here. No change in concavity, so this point right here cannot possibly be a point of inflection. Still concave down, still concave down, because f double prime is negative. All right, to sketch a graph, we're going to come down here and number off that graph. Spread this out a little bit. You don't want a graph the size of a quarter because you need some wiggle room. When we go to graph this in, the first thing that we want to do is to put in those zeros. For f of x, we have a 0 at x is -1, and we have a 0 at x equals 1. Must hit those points, must cross or touch the x-axis, nowhere else, only those 2 points. All right, let's sketch this graph. For x less than 1, x less than -1, so over here this way, our graph has to be decreasing, concave up, coming into a horizontal tangent at x is -1. Decreasing, concave up is going to look like that. Decreasing, concave up, coming into a horizontal tangent right here at x is -1. Then we're changing to, or f of x is changing to decreasing, concave down, going into a vertical tangent at x equals 0, decreasing concave down, going into a vertical tangent at x equals 0. Then from x between 0 and 1, f of x is increasing concave down, going into a horizontal tangent at x is 1, increasing concave down into a horizontal tangent at x is 1. Then when x is greater than 1, f of x turns decreasing and concave down. Decreasing, concave down. And there's the graph of f of x. We have a horizontal tangent right here. We have a horizontal tangent right here and a vertical piece right here where this turns into a cusp.